Okay, for this FRQ, we have a funny looking graph and all sorts of information here. Big thing, g of x is defined as the integral from -4 to x of f of t dt, and the graph is of f. So the first thing we want to do is find g of 0 and g of 4. So if we look at g of 0, that will end up being, we're just putting in 0 for our x's. So the integral from -4 to 0 of f of t dt. So now we can just look at the graph because integral is really just area under the curve. So it looks like from -4 to 1 we have a triangle. You could split it into two triangles, that's good too. But I'm going to look at this as 1/2, the base is 3, and the height is 3. Plus, well, this is not actually a shape we know. So here's where I say, do we have more information? Conveniently we do. Region A is 3. Good thing we know that, huh? Because it's not really an identified shape. So we end up with 1/2 times 3 times 3. Oh, you know what I just missed though? I hope you missed it too. Or I hope you didn't miss it. Hopefully you're thinking, oh, she made another mistake. This is below the x-axis, so it's -3. So now what we end up with is 9/2 minus, well, if we write 3 in terms of halves, it's 6/2. So g of 0 is 3/2. G of 4 will go about pretty much the same. So now instead of -4 to 0, it's -4 to 4 of f of t dt. And -4 to 4, well, we already did -4 to 0. We don't have to calculate that again. So this is -4 to 4 is really 3/2 plus the integral from 0 to 4 of f of t dt. So let's look at 0 to 4. Well, from 0 to 1, that same sentence where we learned what a was, b is 5. So all we have left is that piece. So now, so technically g of 4 is 3/2 plus 5. It's above the x-axis, so we're good, it's positive, plus the integral from 1 to 4 of f of t dt. Looks kind of like a circle. Let's see, they have to tell us what it is, right? Oh, perfect. 1 to 4, f of x is -x² plus 5x minus 4. So we can rewrite this as 3/2 plus 5 plus the integral from 1 to 4 of -x² plus 5x minus 4 dx. We can do this. So 3/2 plus 5 plus the integral of -x² is -x³ over 3, integral of 5x, 5x² over 2, minus 4x, evaluated from 1 to 4. Alright, see we're going to get some ugly fractions, but we can do ugly fractions. Keep the 3/2 and the 5 so we don't forget about them, plus, well, when we evaluate at 4, we get -4^, which is -64 over 3, plus 4 squared is 16, 16 times 5 is 80 over 2, minus 4 times 4, which is 16, minus, now we'll evaluate at 1, -1/3 plus 5/2 minus 4. All right, common denominator, 6. So 3/2 turns into 9/6. This is 30 over 6. Keep the bracket for now. Negative 64 over 3 turns to negative 128 over 6. Now multiply by 3 on top and bottom, 240 over 6. 16 times 6 is 96. Minus, now we'll multiply this by 2, so negative 2 over 6, multiply by 3 for 5/2, 15 over 6, minus 24 over 6. Yay math, yay fractions! Put these together. Oops, sorry, I missed a plus. Put these together, we'll end up with 39 over 6, plus negative 128 plus 240 minus 96 gives us 16 over 6. Negative 2 plus 15 is 13 minus 24 is negative 11 over 6. So we end up with 39 over 6 plus, well, 16 plus 11 is 27 over 6. 39 plus 27 is 66 over 6, which is 11. And we're finally done. G of 4 is 11. Part B. Now we're looking for the absolute minimum value of G on the closed interval from negative 4 to 4. So with absolute minimum, if you'll remember, you have to test critical points and endpoints. So we're looking for when G prime of x is equal to 0. And that will give us critical points. So let's see. Well, what is G prime of x? This is G of x. G prime of x is the derivative d dx of this integral. This is, those fancy rules, for lack of a, more mathy way to put it at this moment. Put in your x, so you just get f of x. So we're really just looking for when G prime of x, which is actually f of x, is equal to 0. We'll make a little table. And again, we're looking for G of x in here. It's not G prime of x, it's not f of x. We're looking for the values. And now technically G of x is the total area under the curve at that point. So where is f of x 0? Well, it's 0 at negative 4, but that's really our endpoint. It's 0 at negative 1, 0, and 1. Those are all critical points. And it's also 0 at our endpoint of 4. And again, you can't have relative maxes or mins at endpoints, but you can have absolutes. Okay, so now let's find our values. Again, we're looking for total area under the curve. Well, at negative 4, it's just a starting point. So the area under the curve there is just 0. At negative 1, we have this area under the curve. And we already knew that was 9/2 from our work before. I make that 4.5 just 'cause. At 0, we had our 9/2 minus 3. So 9/2 minus 3 was 3/2, or 1.5. Again, we're calculating the total area, basically starting at the end point and continuing. We get to 1, we're adding 5 to that. So we have 1.5, we add 5, we get 6.5. And to 4, we add that area, which we found on the other page. If we go back to that integral, that was 27 over 6 over 9 halves, which was 4.5. If we add 4.5 to 6.5, we get 11. And again, when you're finding absolute minimum, you're really just looking for the lowest value of the y's. So the absolute minimum value of g is 0. So that's the smallest value I see, which occurs at x equals -4. Part C. Now we're looking for when the graph of g is down, and give a reason. Concavity is second derivative, so we want to know when g double prime of x is less than 0. And that'll tell us concave down or negative concavity, I guess. So we know g of x is this integral. We found in the previous part that g prime of x was f of x. And if that's true, then g double prime of x must be f prime of x. So we need to look for when f prime of x is less than 0. And this occurs when the slope of the tangent line is negative or when f is decreasing. So if we look up here, f is decreasing from starting here to here. So from -2, and now it's like, oh, is that -1/2? Let's see if we have anything else. Oh, must be horizontal tangent, which is what occurs at that minimum at x equals -1/2. Good. So -2 to -1/2. Okay. And it goes up. Another peak is right here. Horizontal tangent at 1/2. Perfect. So another interval where f is decreasing is 1/2 to 1. It also decreases starting here, horizontal tangent at 5/2, and then decreases until 4. So what we know, g is concave down on the intervals -2 to -1/2, 1/2 to 1, and 5/2 to 4, because g prime of x equals f of x equals 0, and g double prime of x equals f prime of x is less than 0.